Okay, so this is the lesson in geometry entitled Segment and Angle Addition Postulates, Midpoints, and Angle Bisectors. Okay, so one definition to start with, two segments that have the same length, those are known as congruent segments. Congruent segments. So in other words, if you know that segment AB, or the measure of AB, equals the measure of CD, that means that you can say segment AB is congruent to segment CD. That is the symbol for congruence. Okay? These two statements can be used interchangeably. And tick marks are going to be used in figures to show congruent segments. So for example, if you see this labeled in the diagram where this segment has one tick mark, and this segment also has one tick mark, then it means that the two segments are congruent. Okay? If this segment had two tick marks and this segment had two tick marks, then it means they're congruent. If this segment had three tick marks and this segment had three tick marks, it means they're congruent, and so on. Okay? So now we're going to move on to a postulate. It's called the segment addition postulate. So I'm going to write it out, and then I'm going to draw a diagram to explain the postulate. Okay? Here's the postulate in words. If 3 points, A, B, and C, we're going to call them. If 3 points, which I'll call A, B, and C, are collinear, and, meaning they're on the same line, and B is in between A and C. B is between A and C. Then I can say the following. AB plus BC equals AC. Now, that might be confusing when you read it in a sentence, so let me draw a diagram that explains what that said. Okay? So I'm going to draw 3 points on a line or a segment. Okay? If 3 points A, B, and C are collinear, and B is between A and C, so I'll call this one A, I'll call this one C, and B is between them. So you can put B anywhere you want in between them. I'll put B right here. Then I can say that AB, this segment, plus BC, this segment, equals the entire segment. That should make sense, okay? If you add up all the individual segments, it equals the entire segment. That's what it means. So let's try example 1. If AB equals 25, find X, AN, and NB. Okay? So what I'm going to do is I'm going to write down this. I'm going to say that AN plus NB equals AB. Okay? If I add up each of the small segments, it equals the entire segment. Now I'm going to substitute. AN is 2x minus 6 plus NB, which is x plus 7, equals AB, which is 25. Solve that for x. So combine like terms on the left, 3x plus 1 equals 25. Subtract 1 on each side, you get 3x equals 24. Divide by 3 and you get x equals 8. Just make sure you answer all the parts of the question. This question has 3 parts. Find x, we just did that. Now we have to find AN, and then we have to find NB. Let's do AN next. AN equals 2x minus 6. And we just established that x is 8. So 2 times 8 minus 6. So 2 times 8 is 16 minus 6 gives you AN equals 10. Now notice how I wrote that. Whenever you say a segment has a certain length, you write the segment without the bar. So there's no bar above AN. Just AN with no bar equals 10. Now let's do NB. NB equals x plus 7. And we established earlier in the problem that x is 8, so NB equals 8 plus 7, which is 15. And you can do a quick check. AN is 10, NB is 15. If you add those together, you get 25, which is what the entire segment equals. You were told that in the directions, that's 25. So that one works. This lesson is pretty long, 5 pages. So page 2, we have a definition at the top, and the definition is midpoint. A midpoint of a segment is a point that divides the segment into 2 congruent segments. It's said to bisect the segment. So for example, let me draw a segment. I'll label the segment AB. And I'm going to label the midpoint. This will be the midpoint M. Because this M is halfway in between A and B. It cuts it up into 2 congruent segments. Okay? It's halfway in the middle. It's called the midpoint. It's the middle point, midpoint. So if M is in fact the midpoint, of segment AB, then it means that segment AM is congruent to segment MB. Example 2, M is the midpoint of RT. That means that this half is congruent to this half because M is the midpoint. Okay, it's halfway in between the 2 endpoints, R and T. So the first half is congruent to the second half. You have to find RM, MT, and RT. So since it's a midpoint, it means that segment RM is congruent to segment MT. Since it's congruent, it means that the measures are equal. So it means that RM equals MT. Now you don't have to write that on a test or quiz, but that's what I'm doing out. So I'm doing 5x plus 9 equals 8x minus 36. Solve that for x. So I'll bring the x over. I'll subtract 8x on each side. So I'll get negative 3x plus 9 equals negative 36. Then I'll subtract 9 on each side. So I get negative 3x equals negative 45. And then divided by negative 3, you get x equals 15. Now you have to solve for RM, MT, and RT. So let's do RM next. RM equals 5x plus 9. And we just established that x was 15. So 5 times 15 plus 9. So 5 times 15 is 75 plus 9 gives you RM equals 84. Again, notice how I write RM at no bar above it equals 84. Now you should know if RM is 84, MT should also be 84 because these should be the same. But let's just do it out anyway just to make sure we're correct. Okay, if you get the first one wrong and you automatically say the next one is the same, then they're both going to be wrong. So let's do it out. MT equals 8x minus 36. And we established earlier in the problem that x was 15. So 8 times 15 minus 36. 8 times 15 is 120. 120 minus 36 equals 84. So by doing it out, I know I got it right because they're both 84. What are the chances of me making a mistake and getting 84 here and making a mistake and getting the same 84 here? Very slow, very slim. So since they're both the same, I'm pretty confident I got them both right. And now finally we have to find RT. That might look a little tricky, but if you think about it, RT is just RM plus MT using the segment addition postulate. So RT is simply 84 plus 84, which is 168. Okay. Now we're going to do what's called the angle addition postulate, which is the same thing as segments, but now we're just going to do it with angles. So the segment addition postulate, if you add all the small segments together, it equals the big segment. Same thing for the angle addition postulate. If you add all the small angles together, it equals the big angle. So here it is in words. If point B is in the interior, that means inside, of angle AOC, then you can say the following. The measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. Let me draw the diagram to show that. We have angle AOC, so AOC. It says point B is in the interior of that angle. So point B is somewhere inside that angle. I'll put it right there. Put it any way you want. Look at what the postulate says. The measure of angle AOB. AOB is this small angle right here. Plus the measure of angle BOC. BOC is this other angle right there. Right there. It equals the measure of angle AOC, which is the entire angle. So if you add up the two small angles, then it equals a big angle. Okay? So a quick example on that. If the measure of angle XWZ, XWZ is the big angle, okay? That's 121. And the measure of angle XWY, XWY is this angle right here. Find the measure of angle YWZ, which is the angle with the star. So we're going to use a segment addition postulate. And again, you don't have to write, we're going to use the angle addition postulate. And you don't have to write this out on a test or quiz. But if I'm taking this small angle plus this small angle, I'm saying it equals the big angle. The entire angle is XWZ. Now I'm going to substitute. The measure of angle XWY, we're told is 59. You want to find YWZ, and you know XWZ is 121. So you're going to simply subtract. 121 minus 59. You get 62 degrees. Now notice how I wrote my answer. Whenever you want to write out that an angle has a certain measure, you put a little m, okay, little m, measure of angle YWZ equals 62 degrees. Okay, 2 more pages. Again, this is a long lesson. In the directions, it tells you the measure of angle ABD is 100 degrees. So this big angle is 100. Find the measure of angle ABC and the measure of angle CBD. So you're going to do 4x plus 2 plus 3x minus 7 equals 100. But just to show you what I'm doing, I'm really doing this. I'm doing the measure of angle ABC, the small angle, plus the other small angle, CBD, equals the big angle, which is the measure of angle ABD. Again, you don't have to write that out on a test or quiz. But now I'm going to substitute. The measure of angle ABC is 4x plus 2. The measure of angle CBD is 3x minus 7. And the measure of angle ABD, the big angle, you're told is 100 degrees. So if you're at home, why don't you try to solve this on your own? So pause the video and try to solve it on your own before watching me go through the problem. The next step is going to be combining like terms on the left. So 7x minus 5 equals 100. Right there. Add 5 to each side. 7x equals 105. Divided by 5, you get x equals 15. But the question said we have to find the measure of angle ABC and the measure of angle CBD. So let's do that. Let's find the measure of angle ABC next. Okay. Now we know from the diagram above, okay, ABC is 4x plus 2. And I'm going to substitute 15 in for x because we know x is 15. So the measure of angle ABC equals 4 times 15 plus 2. That's 62 degrees. And now let's do the measure of angle CBD, which labeled above is 3x minus 7. And we established that x is 15, so 3 times 15 minus 7. So 45 minus 7 is 38 degrees. Now we can check our answer over, remember, because we're told in the original problem that the entire angle is 100 degrees. So if you add up your two angles that you just got, does that add to 100 degrees? Yes, it does. So I know I got it right by doing that. Okay, last page in this long lesson. We have a definition, and it's angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. So let's draw an angle and let's bisect it. So that's my angle. Let's label this X. Let's label this W. And let's label this Y. So that's angle YXW. And I'm going to bisect that angle. I'm going to cut it in half into two congruent angles like this. Okay. Let me label this Z. And since I bisected that angle, I cut it into two congruent angles, I'm going to label that like this. I'm going to put one arc on that angle, and I'm going to put one arc on that angle. Whenever you see a diagram and you see like one arc over here and one arc over here, that means that those two angles are congruent. It means they're the same. I could put two arcs on this angle. If I put two arcs there and two arcs there, it means they're the same. If I put three arcs here and three arcs here, it means they're the same, and so on. So XZ is the angle bisector. So if XZ is an angle bisector, then it means that the top angle, angle YXZ, is congruent to the bottom angle, angle YXZ. That's what it means to be an angle bisector. If you're an angle bisector, you cut an angle into two congruent angles. So, final example. Given that KM bisects angle JKL, so since angle JKL is bisected, it means that this angle right here, JKM, is congruent to this angle right here, MKL. So angle JKM is congruent to angle MKL. Since they are congruent, it means that their measures are equal. So the measure of angle JKM equals the measure of angle MKL. So since they're equal, I can substitute And if you want, JKM is 4x plus 6. If you want to label that, you can. And MKL is 7x minus 12. I'm going to label that. Some people like to label it. Now I'm going to substitute and solve. So the measure angle JKM is 4x plus 6. We're told that above. The measure angle MKL is 7x minus 12. We are told that above. Solve that for x. So maybe pause the video and try it on your own first. Subtract 7x on each side. Subtract 6 on each side. Divided by -3. X equals 6. Make sure you solve the problem. Find the measure angle JKM, it says. The measure angle JKM equals 4x plus 6. You're told that in the directions. And we just established that x equals 6. So 4 times 6 plus 6. 4 times 6 is 24, plus 6 is 30. Again, look at how I'm going to write my answer. I'm going to say the measure angle JKM equals 30 degrees. And if you want to check over your answer, since JKM is 30, MKL should also be 30. So if you do 7 times x, 7 times 6 is 42, minus 12 equals 30. So that's how you can check over your answer. And that is the end of that lesson on segment addition postulate, angle addition postulate, midpoints, segment bisectors, angle bisectors. There was a lot in that lesson. So there you have it.